folks. So we're taking a look at review sheet number 2. I'm going to go ahead and pick out a couple of problems that I think are particularly pertinent for your upcoming test on Tuesday, April 27th. So let's go ahead and take a look at this guy right here. So we have the microscopic view. So we have a beaker of some sort of solution, and this is a zoomed in version of this. We did this under worksheets called concentrations of ions in solutions, if you remember that. So whenever we drop an ionic compound into these solutions, it will split into its positive and negative half, the cation and the anion. So potassium is the cation, sulfate, which is SO4 as a whole unit, is the anion, so it's on the polyatomic ion sheet. So what will we see in this beaker? Well, we'll see 2 Ks with a +1 charge, and we'll see the 1 SO4. And again, that's because there are 2 potassiums, 2 Ks, in the chemical formula, whereas there's only 1 SO4. And please note that I do include the charges on these guys as well to get full credit. Okay? Now, the next part of this question says a student dissolves 8.7 grams of the solid potassium sulfate into a final volume of 1,500 milliliters. Oh, no, thank you. 1.5 liters of water. What is the concentration, the molarity that is, of the resulting potassium sulfate solution? Well, if we remember, concentration, that is molarity, is equal to the moles over the volume in liters. So in order to find the molarity of something, we do need to know the moles and the volume. Well, lucky for us, we already have the volumes given to us in the problem, but we do not have the moles. So we're going to have to first find how many moles of potassium sulfate we're dealing with here, and then we can plug that value into this equation to solve for our molarity. Well, this is a solid substance, it's a pure substance, so our moles of potassium sulfate will be equal to our mass, which is 8.7, over our formula weight, which you can add up 2 potassiums, 1 sulfur, and 4 oxygens. That should come out to be 174, totaling 0.05 moles of potassium sulfate. If we then recall that molarity equals moles over our volume is 1.5 liters, and our moles are 0.05, and therefore our molarity will be 0.033 molar potassium sulfate, K2SO4. And of course, I'm the model student, so I'm going to go ahead and box that up. Now, for these next questions, please pay careful attention to what you're being asked. In these first two, you're being asked for the moles of an ion, the moles, which is a finite number, versus the last two are asking about the molarity. We're talking about a concentration here. What is the ratio of moles and volume? So for this first one, talking about the moles of potassium, and let me get some of this out of the way here, kind of clear this up. Actually, what I really want to do is I want to save this number right here for later. So that's the molarity of our solution. But for this guy, where it says how many moles of K, well, we have 0.05 moles of this whole thing. There are 2 potassiums in every 1 potassium sulfate. So 0.05 times 2 will tell us we have 0.1 moles. Again, we're talking about moles of K+. Whereas the SO4, there's only 1 SO4. There's only 1 piece of cheese in every cheese sandwich. And so that's how many moles of SO4 we have as well. So we have 0.05 moles of SO4 minus 2. Now, in terms of molarity, again, this is our molarity, the 0.033 molar. So that's our concentration of K2SO4, again, that whole compound. Well, then the concentration of our potassium ions alone will be double that. We got a 0.066 molar potassium in solution, whereas the sulfate will again just be the same as the whole compound since there's only 1 sulfate in each one of those. Alrighty. Now if we move on a little bit here, we're going to talk about which solution has a higher number of carbonate, the CO3 minus ions. So please be careful. We're talking about the total number of carbonate, CO3 minus 2, ions. So first thing we're going to do is we're going to notice, those are milliliters, no thank you, 0.3 liters. 0.5 liters. Make sure future you never has a chance to accidentally use 300 or 500 in their calculations. Well, let's find the moles of our two different compounds here. Remember, the moles of a solution will be equal to the molarity times the volume. In this case, that's going to be our 0.5 times our 0.3. And so we have 0.15 moles of sodium carbonate. Again, this is also a solution with our aluminum carbonate, so molarity times volume. In this case, that's our 0.25 times our 0.5, which then comes out to be 0.13 when we round moles of aluminum carbonate. Now, some people will be like, all right, cool, this one has more carbonate right there because 0.15 is higher than 0.13. But be careful. On the left, we have moles of sodium carbonate, not moles of carbonate, moles of sodium carbonate. On the right, we have moles of aluminum carbonate. Sodium carbonate and aluminum carbonate are two completely different things, and so we can't compare those apples and oranges. So if we want to compare these two, we need to first make sure they have the same units. So we got to scratch that there. So with the sodium carbonate, we have that many moles. Well, there's a 1-to-1 ratio between sodium carbonate and just simple carbonate. So we have 0.15 moles of just carbonate. Again, that's what the problem originally asked us for, right? Or it asked us for how many carbonate ions are we dealing with. And we're going to convert our aluminum carbonate into the same units over here. So we have 0.13 moles of aluminum carbonate. However, there's a 1-to-3 ratio of aluminum carbonate to carbonate since we have 3 carbonates in every aluminum carbonate, which means that we have 0.39 moles of carbonate in our solution on the right, our solution B. Again, notice that there are 3 carbonates, 3 of this whole thing in parentheses, in this second solution. And so this is truly our final answer, where we have 0.39 moles of carbonate in solution B, which is a lot more than 0.15 moles. So there's that. This problem right here, it's a nice little limiting excess Stoich. It's a great practice problem. I strongly suggest you try that one, number 3. And that will be it for review sheet number 2. There's a lot of other practice. This question right here, number 7, is particularly tough. But if you can do a question like that while you're practicing, you should feel an increase in your confidence going into your Unit 7 test coming up next Tuesday. That is April 27th. Okay, so that's it for review worksheet number 2. Stay tuned. Maybe look in the next folder for a brief video that goes over a problem or two from review sheet number 3. All right, folks, I will see you later.